All right, guys, we are going to be learning how to factor algebraic expressions. Our objective is I can factor algebraic expressions by taking out a common factor. Looking at number 1, it says factor 2y plus 10. Well, in order to factor, I'm going to write this note, we must find the coefficient, the GCF of our coefficients. So our coefficient is 2 and 10. So we're going to write our GCF. This is where we're going to find our GCF. So we're going to do 1 times 2y equals 2y, and 2 times 1y equals 2y. And then for 10, we have 1 times 10 equals 10. 2 times 5 equals 10. And 5 times 2 equals 10. So looking at this, our GCF is going to be 2 because it's the highest factor that both 2 and 10 have. So now that we know what our GCF is, we now can factor. So we know that 2 times 1 equals 2y, so we're going to write that 2 times y plus, because it was adding, and 2 times 5, because our factor is 2, times 5. So now we're going to take our 'two's out of the equation because we're going to put them on the outside of our parentheses. And now what we have left is y plus 5. So we write y plus 5. Now we have an expanded form. This is how after we factored, what our final answer would be. And you can check your work by expanding. So we could do 2 times y and 2 times 5. 2 times y gives us a positive 2y, and 2 times 5 gives us 10. And since it was adding, we're going to have 2y plus 10. And this is the same, so it is correct. So looking over here on the right-hand side, we have a math question. What do we know about the word expand? Well, we know that expand means that we need to multiply each term by the expression outside of the parentheses. Looking at number 2, it says factor 6z minus 9. So remember, in order to factor, we have to find the GCF of our coefficients. So we have 6z and 9. So we are going to do 1 times 6z equals 6z. We have 2 times 3z equals 6z, and 3 times 2z equals 6z. As far as our 9, we have 1 times 9 equals 9. 3 times 3 equals 9, and 9 times 1 equals 9. Our GCF for this to be factored between 6 and 9 is 3, I apologize. Say both, the highest number that each 6 and 9 is 3 for their factor, their GCF. So now that we know that, we're going to take these numbers and these numbers right here, and we are going to rewrite it. So now instead of having 6z, we now have factored 3 times 2z, and it was a minus sign, so now we put a minus in the middle. And then for the 9 we had 3, remember 3 was our GCF, times 3. And now we need to take our GCF, our common factor, and we're going to stick it on the outside of a parentheses. And we're going to rewrite what numbers we have left, which was 2z, a minus sign, and a 3. So now we have 2z minus 3 is our factored form. And that would be our final answer after we have factored. And remember, you can check your work by expanding. So we would take our 3 and we would expand it in. So now we have 3 times 2z, which gives us the answer of 6z. And we have 3 times, remember it was a negative number, so we're just going to write our negative sign right in the middle already. 3 times 3, which gives us the answer of 9. So after we've expanded, we get 6z minus 9, which is the same as number 2. So it is correct. Our factored form is correct. Looking over here on the right-hand side, we have a math question. It says, how can we use our understanding of factors to write each expression in its simplest form? Well, we can use our understanding of GCF to find the common factor for both of our terms to get at the simplest form for factors. We're going to look at number 1, some practice problems. It says factor 6p plus 6. If you want to take some time, go ahead and try factoring this on your own, and we'll come back and see if we have the same answers. All right, so we have to find our GCF first. So GCF of 6 and 6, well, it's the same exact number. So if we have 1 times 6p equals 6p, and 6 times 1p equals 6p, and then we have same exact, except instead of p, which is p, 6 and 1. So we know our greatest common factor is going to be a 6. So we have 6 times p plus 6 times 1. So we would take our common factor and stick it on the outside of our parentheses. And these are our leftover components that we need to stick on the inside of our parentheses. So now we would have p plus 1. And you could check your work by expanding. So now we would have 6 times p and 6 times 1, which 6 times p gives us 6p, and 6 times 1 gives us 6. So our final, the factored form would be 6p plus 6, which does match number 1. So we know that our factored form is correct. Looking at number 2, it says factor 4x minus 6. If you want to go ahead and stop the video, try factoring on your own, and we'll come back and see if we have the same exact answer. So we can find our GCF first, which for 4x, we have 1 times 4x gives us 4x. We have 2 times 2x equals 2x, or I mean 4x. And then we have 4 times 1x equals 4x. And then for 6, we have 1 times 6 equals 6. And 2 times 3 equals 6. We have 3 times 2 equals 6. And 6 times 1 equals 6. So we know our GCF, our common factor, is going to be 2, because it's the greatest common factor in both 4 and 6. So now that we know our GCF, we can use what we have found. So now we'll have our 2 is our common factor times 2x, And then we have this minus sign right here in the middle, so we got to continue with our minus sign. And then our common factor was 2 again, times 3. So now we have to take out our common factors and stick it on the outside of parentheses. Now we'll have a 2 on the outside. We have to use all of our leftover components and stick it on the inside. So now we have 2x minus 3 is our factored form and our final answer. And if you want to check your work, you can go ahead and use you can expand to see if the answer is correct. Looking at number 3, it says factor 8 plus 6y. If you want to go ahead and try this on your own, you can. We can come back and we'll see if they're the same answers. So we have 8 plus 6y. We got to find the GCF to start off. So we have 1 times 8 equals 8. 2 times 4 equals 8. 4 times 2 equals 8. And 8 times 1 equals 8. And for 6, we have 1 times 6y equals 6y. 2 times 3y equals 6y. 3 times 2x, or y, equals 6y. And 6 times 1y equals 6y. So our GCF, our common factor, is actually going to be 2 because it's the highest number, the greatest common factor in both 8 and 6. So now that we know this information, we can take our common factor, so 2, and 2 times 4 equals 8. Oh, let me write that in a different color. So 2 times 4 equals 8. We have this plus sign in the middle, so we have to add. We have 6y, and our common factor was 2, so we have to do 2 times 3y equals 6y. We got to take our common factor, which was 2, stick it on the outside of our parentheses, and we have to finish with our rest of our components was 4 plus 3y, which we stick that on the inside, which would be 4 plus 3y, which would be our final answer. And you could go ahead and use the expand method, and if it turns out that you get the same as 8 plus 6y, then we know that we factored correctly. Lastly, we are going to look at number 4, and it says, are these pairs of expressions equivalent? 4 parentheses y minus 4 and 16 minus 4y. Well, we learned that we can take any expression, any number and place it in for the variable when we're working with equivalent expressions. So we're going to take y equals 1. So I'm just going to split this right down the middle, and we're going to substitute 1 in for y. So now we are going to have 4 times 1 minus 4. Since we are expanding, we got to take our 4 and multiply by each expression on the inside of our parentheses. So now we're going to have 4 times 1 equals 4, and 4 times 4 equals 16. And since it was a subtracting sign right in the middle, we got to make sure that's our middle expression. So now we have 4 minus 16, and 4 minus 16 gives us the answer of negative 12. I'm going to write that right down here so that we can find out whether these are equivalent or not. Looking over here, we have 16 minus 4, and we are substituting 1 in for y. So now we have to do 4 times 1 equals 4, and we have 16 minus 4 now, which gives us the answer of 12. And we would say that these are not equivalent expressions because they are not the same value. We have a negative 12 and a positive 12.